Hello students, in this video we will learn about the quadratic formula. So in the previous videos we have learned that to find the roots we can do it by the factorization method. So this is another method in order to find roots, that is by using the quadratic formula method. So let's look at what is the quadratic formula or what does it say. As per the quadratic formula, if we need to find the roots, this is the formula: x equal to minus b plus or minus square root of b square minus 4ac, the whole thing upon 2a, where a, b and c are real numbers, okay, and where a is not equal to 0. Okay, so this is how we find. So this is the formula which we call as the quadratic formula. Okay, and the how do we get b a c? From where do we get that? So that is from our general quadratic equation, that is ax square plus bx plus c equal to 0. Okay, so this a, b and c that you see is from here. A is from here, b is from here and c is from here. Okay, so the values of this we need to put in this formula to get the value of x. Now b square minus 4ac. Now b square minus 4ac is also known as the discriminant. Okay, it is known as the discriminant and it is denoted by capital D. We write sometimes D equal to b square minus 4ac. What is the significance of this discriminant? See, if this discriminant is equal to 0 or if the discriminant is greater than 0, then only we have real roots. If the discriminant is less than 0, which means it is negative, then in this case the quadratic equation has got no real roots, or it will have two imaginary roots. Okay, so two imaginary roots. If d is equal to 0, then it will have, the quadratic equation will have equal distinct roots, and if the discriminant is, cancel this part, if d is equal to 0, then it will have equal real roots, and if d is greater than 0, okay, then the quadratic equation will have two distinct real roots, and this formula can then be replaced and written as x equal to minus b plus or minus square root of d, because d is nothing but b square minus 4ac, whole thing upon 2a. Before we go to find roots or not, we can find out if the equation does have any roots or not, because if the equation is not going to give you any roots, there is no point in solving further. Fine, we'll look at it when we start solving problems, but for now we'll focus on the discriminant, on how important role that it plays in this quadratic formula. Now let us take an example to understand what do we mean by d is equal to 0, that the quadratic equation has got real equal roots, or it has just one root. Okay, let's have a look. Let's take an example, a quadratic equation. We'll solve for a quadratic equation and see. Our first equation is x square plus 6x plus 9 equal to 0. So if we have a look and compare it with our general equation, which is ax square plus bx plus c, we see that a is equal to 1, b is equal to 6 and c is equal to 9. Now we need to put this in our discriminant formula, which is d is equal to b square minus 4ac. b is 6, so 6 whole square minus 4 into a, which is 1, and c, which is 9. 6 whole square is 36, minus 4 into 1 is 4, 4 into 9 is 36. 36 minus 36 is 0. Okay, so this tells you that discriminant is 0 and it applies for this particular equation, quadratic equation. So what would be the quadratic, what would be the roots of this quadratic equation? Will you solve this and get the roots of this quadratic equation by using the quadratic formula? So I'll do this over here, and we say x is equal to minus b plus or minus square root of d, since we've already found out d, whole thing upon 2a. Now minus b, b is what? 6. We put minus 6 plus or minus square root of d. D is what? Equal to 0. And 2a, a is 1. So into 1. So we get minus 6. So plus or minus square root of 0 is 0. Whole thing upon 2. So ultimately we get what? Minus 6 upon 2, which is equal to minus 3. So we get x equal to minus 3. We are getting only one root in this case. And if you notice carefully, this is actually in the a plus b whole square form. Okay, x equal to minus 3 means x plus 3 into x plus 3 equal to 0. See, if we were to actually find out the roots from here, this we would have written it as x plus 3 equal to 0, which would have been x equal to minus 3. So this is what we've got over here, right? So x plus 3 into x plus 3. So we are getting just one root, and they are equal roots, or we can say they are equal roots. So this, we can say that x equal to, so the roots of this particular equation, that is x square plus 6x plus 9, is nothing but minus 3 and minus 3. Equal roots, that's what we say, real equal roots. These are real numbers, equal roots, or we say one root only for that. That happens only when we have over here perfect squares, as in the identity form. Let's check out what does it mean by d greater than 0. When d is greater than 0, the quadratic equation will have real distinct roots. With the help of an example, we will understand what does it mean by d greater than 0 giving us real distinct root. We take a quadratic equation, x square plus 3x minus 8. So x square plus 3x minus 8 equal to 0, and we compare it with our general form. The general form is ax square plus bx plus c equal to 0. So if we compare it, we get a equal to 1, because that is the coefficient of x square, b equal to 3, which is the coefficient of x, and finally we get c equal to minus 8. Now we use these values and put them in our discriminant formula, which is d equal to b square minus 4ac. b is 3 whole square minus 4 into a, which is 1, and c, which is minus 8. 3 whole square is 9. 4 into 1 is 4. 4 into minus 8 is minus 32. Minus 32 and minus gives us plus 32. Plus 32 and plus 9 will give us 41. This implies that d is greater than 0, which means our quadratic equation has real distinct roots. Now that we have found out that the quadratic equation for certain has got roots, we go to find the roots using the quadratic formula, and that is x equal to minus b plus or minus square root of d upon 2a. minus b. b is 3. So minus 3 plus or minus square root of d, and d we have found as 41. Whole thing upon 2a. A is 1. This can be further written as, we write x over here, x equal to minus 3 plus or minus square root of 41 whole thing upon 2, which means we have got two roots now, which is x can be equal to minus 3 plus square root of 41 upon 2, or x can be equal to minus 3 minus square root of 41 upon 2. These are the two distinct roots of this quadratic equation, x square plus 3x minus 8. And how do we get plus and minus? See, the plus and minus sign changes over here because we are assuming that it can be plus or minus. Fine. So that is how we get two distinct roots over here. Now that is only possible when we get d or discriminant greater than 0. What if the discriminant is less than 0? If the discriminant is less than 0, then we do not get real roots. We get imaginary roots, or we can say no real roots. In our number system in class 9, we have studied about real numbers and imaginary numbers, where we continue studying more and more on real numbers. As you go to higher classes, you learn also about imaginary numbers. We do not learn in this class about imaginary roots or imaginary numbers. That is why if we happen to get d which is less than 0, anything will be negative. If we get less than 0, it implies that they have imaginary roots, and we stop till there. We do not go to solve using the quadratic formula, because remember, quadratic formula is used only where you can get real roots, real numbers roots. Because even here it uses real numbers. A, B, C are real numbers, it says. But we'll take an example to find out in which cases we get d is less than 0. We'll take an example. X square plus 4x plus 7 equal to 0. And we compare it with our general form, ax square plus bx plus c equal to 0. So a will be equal to 1, b will be equal to 4, and c will be equal to 7. Now we use these values and put them in our d equal to b square minus 4ac formula. And let's see what do you get. B is equal to 4. So 4 whole square minus 4 into a, which is 1, and c, which is 7. 4 whole square is 16. 4 into 1 is 4. 4 into 7 is 28. So 16 minus 28 gives us minus 12. Minus sign coming from the sign of the greater number. This suggests that d is less than 0. So numbers less than 0 on the number scale, okay, are said to be negative. It's an integer. However, when it comes d is less than 0, this implies that quadratic equation has no real roots, or we can say that it has imaginary roots. But when it says it has got no real roots, we do not go and use this formula, because this formula is only to find roots where they are real numbers, not imaginary numbers. Fine. So when it comes d equal to less than 0, we stop till here and we do not go to use this formula. So just as a recap, if we revise the whole thing what we have learned in this particular video, we have learnt about the quadratic formula, which is x equal to minus b plus or minus square root of b square minus 4ac, where a, b and c are real numbers, and these are coefficients of your x variable or whichever variable that is present. It could be y, z, whatever, where a should not be equal to 0. What happens if a is equal to 0? Fine, you anyways, it's okay, it doesn't matter if it is 0, everything over here will become 0, or b square minus 0 it will become. But remember, there is a also in the denominator. So if a becomes 0, then this entire thing becomes not defined, or we do not have a value for that. Again, it will go into imaginary numbers. So we cannot afford that. As a result of which, we clearly specify that a should not be equal to 0. Next, what we did is, we broke this b square minus 4ac into a different formula. That is, we call this as a discriminant, and this discriminant plays a very huge role in determining whether the given quadratic equation has got roots or not, real roots or not. And we found that when d greater than or equal to 0, we get real roots. But when d is less than 0, the quadratic equation has got no real roots. See, no real roots. Remember, there's a difference between no roots and no real roots. These do have roots, but they are imaginary roots. But we are interested in only real roots. So that's why we say no real roots. Okay. With this, we cover the basics of quadratic formula, and now we are ready to solve some problems based on quadratic formula to find out roots. So this is another method to find out roots. The first method that we learned was factorization or splitting the middle term. This is another way to find out the roots of a given quadratic equation. If you have liked the video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon. Thank you for watching. See you in the next video.